Well, welcome. This is the next FP1 proof by mathematical induction. So in the last video, we looked at proof that we could use a formula, okay, where there were positive integer powers, okay, and we looked at how we can prove that is any number in that is divisible by 4, or whatever number it might be, okay. Now this time we're going to prove the same thing, but instead of having it as powers, we're just going to have it in a standard type of equation, such as this. Okay, so as it's principally the same to the last video, okay, you do the same things in terms of you say, in this case it was it must be divisible by 3, okay, so we sub 1 in and see if that is divisible by 3, and if it is, we assume the rest are, okay, so f of 1 cubed takes 7 times 1 plus 9, well that's obviously equal to 1 take 7, well that's quite clearly 6, plus 9, well it's obviously 3, okay, and 3 over 3 is 1, so therefore this equation is divisible by 3. But obviously we've got to prove that it's this particular equation. So the first thing we do is assume it's true for n equals k. So assume true for n equals k. Okay, so what you do here is you simply just sub in n to be k in the left hand side and the right hand side, split it up if you want to. So f of k is equal to k cubed take 7k plus 9. Yeah, and if it's true for n equals k, obviously you assume it's true for the next term for n equals k plus 1. Okay, so you just sub k to plus 1. So therefore f of k plus 1, well that's k plus 1 all cubed, take 7 times k plus 1 plus 9. And what you have to do is, what we're going to do now is expand this out, okay, so we've got a full answer, and then what we're going to do then is do f of k plus 1 minus f of k. Okay, so I'm just going to expand this out for you. Okay, so it's k plus 1 times k plus 1 times k plus 1 take 7k take 7 plus 9. Okay, and it's just a case of expanding this, double brackets, triple brackets even. Okay, so it's obviously k squared plus 2k plus 1 times k plus 1 take 7k take 7 plus 9. Okay, so then it's just times in this quadratic by k plus 1. Okay, so obviously if you do that, times it all by k first, then times it all by 1, add them together. Okay, so it's k times k squared, well that's k cubed, k times 2k, well that's obviously plus 2k squared, and k times 1, well that's just plus k, and then we times it all by 1, so plus k squared plus 2k plus 1, and then that's taking 7k minus 7 plus 9. Okay, and then it's just a case of simplifying this down. Well, it's just simplified down to k cubed plus 3k squared. Well, it's plus k plus 2k take 7k. In other words, 3k take 7k, which is obviously minus 4k, and then you have plus 3. So minus 4k plus 3. So the expansion of all of that, so k plus 1 all cubed, take 7 times k plus 1 plus 9, simplifies down to k cubed plus 3k squared, take 4k plus 3. Okay, and that is equal, remember, to f of k plus 1. And it's crucial to remember that because this next step says what we do is we do the f of k plus 1, take the f of k. Now the reason we do that, okay, is because we assume the increase in the next step, so k plus 1 just represents the next unit, the next series, or whatever it might be, okay, the next answer. and the jump will be exactly the same. You can think of it like that. So therefore we're measuring, well, if that's the jump is the same each time, what's the difference between these two? Okay, so hopefully you don't really need to understand why so much, but just need to remember that. Okay, so we said f of k plus 1 is equal to all of that. Okay, so k cubed plus 3k squared, take 4k plus 3. Okay, so that's k cubed plus 3k squared, take 4k plus 3. And from that we are taking away f of k, which is that. So it's k cubed, take 7k plus 9. Okay. Okay, so obviously the k cubed cancel, and the k squared, well, it just remains k squared, so 3k squared. The k's, okay, so it's minus 4k minus 7k, in other words, minus 4k plus 7k, so it's plus 3k, and then 3 minus 9, well, that's obviously minus 6, okay? So out of this, what we do now, so that's, I think that was a third or fourth step, okay, and then, yeah, that was a fourth step, getting to that stage of, in the last video for integer powers, okay, what we did was we came up with a couple of steps, and the next step is factorising this, okay, so taking 3 out as a common factor, so k squared plus k, take 3, okay, so therefore, as it's 3 times all of that, we can say therefore, because it's 3 times all of that, it's therefore divisible by 3, okay, and you would say therefore that is your proof. Okay, so that is your answer for proving that the equation is producing numbers which are divisible by 3. Now, I probably put the more mathematical title on there, but sorry, it's just not coming straight to my mind at this point. Okay, so very, very similar to the powers explanation, but obviously we're just dealing with non-integer powers. Okay, but the principle remains the same. So the next one, obviously, I don't know if I mentioned it, but there are a few more. It's not just matrices left. Obviously, depending on where you've got up to. The next set of videos, proof of mathematical induction, are going to be looking at recurrence relations, and they are very easy. Okay, so thanks for watching. Hopefully, we'll see you in the next video.